And that's what we're going to do this week. But we're going to review for the quiz tomorrow and then hit on this again. But it's like g of f of x. That's a composite function. Function inside of another one. What are the functions inside in a Tootsie Roll Pop? First, what's on the outside? The wrapper. Well, first you have to undo the wrapper, right? And then what's next? The delicious part, right? The candy. You don't like the fudge part?
I don't like Tootsie Rolls. They don't taste good.
Oh, so you'll eat the outside and probably throw it away.
Well, I'll eat the inside because theirs is like my favorite part of the candy.
Okay. Hey guys?
So it's really like H.
It's h of g of f of x. That would be correct.
So good.
Okay. So when we do derivatives, Wenfei, of composite functions, we have to figure out what we're going to do. So here's a simple example. And these are from old classes, so I don't even think I have a Sue this year. Sue can run 3 times as fast as Matt, and Matt can run twice as fast as me. How many times faster can Sue run than me? 6. What'd you do with these rates? These are rates. You multiply them. So it's 3 times 2, so the answer would be 6. That's what we're going to do with the chain rule. Now, we have to understand that this d dx is not a dy dx. It's an operator. It's like a plus sign or a minus sign. When you do 2 plus 3, and you say that's 5, where did the plus sign go? You used it up. It's an operator. This plus sign says take these 2 numbers and add them. So when you do the derivative with respect to x of x squared, then you say, well, I want to find the derivative of x squared, which is 2x. Okay? We have to talk about with respect to x. I could talk about how x squared changes as something else changes. So when I say that dx of x squared is 2x, then finding how x changes as, I'm trying to see how x squared changes if I change the x value. It's a ratio of 2 changes. Okay, and I was going to have a lab, but anyway, I didn't get around to writing it. What about the derivative of this function? F of x is equal to x squared minus 3x plus 4. Now, I don't like the u substitutions that the book uses. If you like them, use them. If they help you, you can read the book and see. I just think it's too confusing. It's just easier to do this. And when I walk out of here, I want to say, everybody say, I get this. But of course, you know, you go home and then you look at it and it's just not the same, right? It is the same, but you feel like it's not the same. I have 2 functions in here. What do I have? I have an outer function and I have an inner function. I have something to the what? 60th. And then inside, I have a quadratic. So I want to see how things change relative to other things. Some of you will just kind of memorize this, and that works, but it's nice to understand when we get to implicit differentiation. It's going to be a big thing. So I want the derivative of this with respect to x. So first I'm going to do the derivative of the outside function with respect to whatever is in there. I'll just do that. And then that's how the 60th power will change as I change this parabola. And then I'll say, well, what's the derivative of the parabola as I change x? So I'll just put an x here for right now. Here's how you do it. You look at the outside function. So what's the derivative of the 60th power? 60 times whatever's in there. Now what power is it going to be? 59. You do not change whatever's in there. This is like unwrapping the wrapper on the Tootsie Pop. You didn't change the candy, did you? You take the derivative of the outer wrapper. So I first do the wrapper, and then I'm going to, this is still going to be x squared minus 3x plus 4. And then we are going to multiply it by the derivative of the inside. So now we're going to get to the candy. We're going to take the derivative of the candy. What's the derivative of this inside function? I want to go back to the original. Yeah, 2x minus 3. And you're done. You just leave it. Never. We'll worry about simplifying right before the exam if we have to have that. So, I'm not sure what my in general says. It's probably on your sheet. In general, I do the derivative of the outside function, that's f, with respect to whatever the inside function is. I know you'll be able to do this, but when I come to implicit differentiation, it's going to bother you. So I'm taking the derivative of f with respect to g. Let me put it simpler. The derivative of f with respect to g, because I can actually justify this algebraically to you, at least I can argue it better, times the derivative of g with respect to x. Algebraically, if we don't know any calculus, what happens to the dg's? They cancel. And don't I get df, dx? So what's happening is I'm going to, sorry, you don't get dx if I don't write the d there. Yeah, I would say so. Okay, what I'm going to do is change x. So if I change x, then the g function is going to change a little bit. And if I change the inner function a little bit, what's going to happen to the outer function? It'll change. So if I take the volume of a balloon, assume it's a sphere, 4/3 pi r cubed, and I want to see how the volume changes as time changes. We're going to be doing a lot of this. Well, that's a constant. Remember, pi is just a number. Actually, this is about 4. So we're going to ignore the constant because we can. And then I'm going to take the derivative of r cubed, but with respect to r. How does r cubed change if I change the radius? And then, how does the radius change if I change time? If I read it backwards, let's read it backwards. Oh, sorry, it should be dr cubed. Happier. Well, you can get dr over dr. What would dr over dr be? 1, but not in this case. So if I change, I'm blowing up a balloon in time. What's going to change first? The radius is going to change, right? And if you change the radius, what's going to happen to the volume? It's going to get bigger, hopefully. And so when you do this derivative, you're going to get the change in the volume and the change in time. This is just intro. Don't worry about mastery on this piece. What's the derivative of r cubed? That's 3r squared. That's the derivative with respect to that inside function right there, or the outer function, sorry, times the derivative of the inside function with respect to time. But we'll be doing a lot of this. This is called a related rate. Because remember, what's a derivative? A derivative is a rate. It is. What is it over? It's over 1. Okay? But it's no big deal. And you can cancel that out. So that's just an introduction. So let's do some problems. And we could always do these by squaring that out. I could do the second one with a trig identity. I can't do the third one. Well, I probably could with a trig identity. It's still composite. Do you not have this page? Did we miss a page?
We have deer dick.
Oh, we're missing a page. We're going to do, no, we got to start with the easy stuff. Yeah, if you need paper, I got paper. Does anybody need paper? Not too much space. Let's do this. Some of you want to just say, because remember we talked about this a while ago, actually. I wonder why that's not on there. You start with example 1 and 2, and they're just totally missing this. Okay. Oh, yeah. As much as you want. This is mistakes from me making copies. Some of you might want to just say, well, the derivative of this with respect to x, I can take the derivative with respect to anything I want, is just 2 times 3x plus 2. Well, let's do this another way, because no matter how I do math, I can do things different ways, but I got to come up with the same answer. So could we expand this? Sure. Does anybody know what this is when I multiply it out? Careful, you're going to square it. It's 3x plus 2. Let's multiply it out, because I got to get the same answer there. Okay, so it's 9x squared, because we know how to do this, right? Plus 12x plus 4, which doesn't matter, because what's the derivative of 4? 0, right? What's the derivative of this? 9x squared, what's the derivative of 9x squared? 18x plus 12. Now, if you guys wanted to multiply this out, I shouldn't have stopped you, but what does this multiply out? 6x plus 4. I know the second one's right. I know that's right. So this needs to be multiplied by what? 3. Where is the 3 in my problem? It's the derivative of the inside function. So I'm trying a variety of ways for you to see. You got to chain, and you just multiply your rates together. You chain it together. That's why I go chain, chain, chain. Now I could do this 2 ways. Do you know the identity for this? This was the identity you need to know. This is 2 sine of x. That's not good enough. Because that has an amplitude of 2. This has an amplitude of 1. Not the same. Times what? Anybody remember it? You might not have seen it. I don't know. Cosine of x. Okay, what rule do we have to use here? I could do chain rule, which is a lot easier. And I could use product rule here. So what's y prime? It's 2 times, it's the sine of x times the derivative of the cosine. What's the derivative of the cosine? Do you remember? Negative sine of x. Sorry, I'm going to move that up. Well, these you got to know. Plus, and then it's the cosine of x, right? Times the derivative of the sine of x. What's that one? Derivative of sine is cosine. So I get, and I did make a mistake, by the way, last week on my video and on my slide. I missed the negative sign that was out in front on one of those last problems. Sorry. But this is 2. And I'm going to multiply these together. Cosine squared of x. I like to keep my positive ones in front. Minus sine squared of x. And I bet I need a trig identity. Nothing wrong with that, by the way. But if I'm on the exam and you had to match it, I might be in trouble. Now let's do this with the chain rule. Because I like that better. Y equals, I think it's easier.
So this first one, are you just using the product rule?
I used the product rule. Because I didn't have to know the chain rule here as long as I knew this identity, right? As long as I knew that identity, I was okay. This one I'm trying to remember what it is. I think I know. What's y prime here? Now, we do the derivative of the outer function. So you ignore the 2x. It's a composite function. It's a line inside of a trig. What's the derivative of sine? Cosine of 2x. And then now you have to do times the derivative of the inner function, which is times 2. So it's 2 cosine of 2x. If I were to look up my identities, cosine of 2x is equal to this. I don't, well, that's an identity you really should know. That's another one. So we have the sine of 2x, that's one identity. They don't always have the parentheses on the exam, though, by the way. You need the cosine of 2x, you might want to write this down, and you need sine squared of x plus cosine squared of x is equal to 1. It used to be you had to know more identities in the past, but that was before we had calculators. Well, we had graphing calculators, 91. So in the 80s, if you go back and look at those exams, you had to know a lot more. But you don't have to know it now, because everything's on your calculator. So that is de-emphasized. I can get you an identity sheet, but these are all you need. It's all you need to know for my class and for the exam. The sine of 2x is this one. Cosine of 2x is this one. Okay, so let's do this. There's a sum and difference identity. I still have to use the chain rule. So what's y prime here? So now, what I do is I cover up the inside function. I take the derivative of the outside, which is negative sine of, and it's whatever's in there. What's in there? X cubed minus 4x. And then you go to the next function and you take its derivative. So what's the derivative of x cubed minus 4x? 3x squared minus 4. I prefer to write this 3x squared minus 4 out in front, just so I don't think it's multiplying times that angle, because it's not. So on your quiz on Wednesday, you're going to have some of these. So it includes through this, through the chain rule. But you're going to get a partner. Formative, so that's okay. And partly because, you know, we're trying to get through and make sure we stay on our schedule so that we're ready. Okay? Now, I don't know what the next slide looks like. Pretty to look. Hopefully it's yours. We did that one. Oh, it doesn't look like yours at all. That's it. There it is. Let's do that one, then we can come back to those other ones. Oh, this looks painful, doesn't it? Does it look painful? Because what do I have? On the outside, I have the power. On the inside, I have the, the function, which is, and I have to use the quotient rule. Okay, so you ready? So first, I do the outside. Just ignore what's in there. It doesn't change what's in there. Because what I'm doing is taking the derivative of the 6th power with respect to all of that stuff that's in there. Okay. I don't want that. So it's going to be 6 times whatever's in there, 2x plus 1, 3x squared plus 2. I'm going to slide that over. I wasn't thinking. Ah! And then what do we have to do? Oh, I missed the 5th, didn't I? To the 5th times. And then we have to do the derivative of the inside function. Which one do we start with? Quotient rule. Denominator or the numerator? We start down and we go up. And then we go back down. If you're on the main level, that's how I figure it out. That's how I remember it. So I'm going to start with 3x squared plus 2 times the derivative of the numerator. What is the derivative of the numerator? 2 minus, am I going okay? Slow enough? Then it's what? The numerator times the derivative of the denominator, which is 6x.
That's the low.
Right, because this is the low, and this is the high. So it's low, d high, minus high, d low. And you know on the exam that they're going to give you the reverse of that in their multiple choice. You've seen it. You know that's going to be one of the choices. Read through all the choices. Over the square of low we go. Do I need to square this out? No. Don't waste your time. And I could simplify all this other stuff. I certainly should be able to simplify the numerator. And just because we have some issues with negative signs, let's go ahead and do that. I'm going to leave the rest of the stuff alone. I could do some simplifying with it, but I don't really care. So it's 2x plus 1, 3x squared plus 2 to the 5th power, and now let's go ahead and multiply that out. I don't have problems with the first one. That's 6x squared plus 4. Now we might have some problems. What's the sign going to be? Minus. So multiply these together. What do you get? 12x squared. What's the next sign going to be? Minus 6x, right? I got to do this guy. And in pre-algebra, I draw the arrows, and I've been drawing the arrows for a long time. I still draw the arrows. I still might mess up. Did I do that right? All over the denominator squared. Some of you might say, well, I could group that with the 3x squared plus 2 to the 5th. Yes, you could. And then we can simplify that. Oh, let's see what happens. What do I get? 6x squared minus 12x squared is negative 6x squared minus 6x plus 4. And the only reason why I'd want to do that is to see if I could maybe factor and reduce it to that, but it's not going to happen. Yes, I could. It doesn't matter. All over this. Suppose you guys want this. I should write it correctly. So, yes, you could factor it too. It just doesn't do us any good. So as far as I'm concerned on your homework, though, You do not need to simplify. You can stop right there. But then you will need my solutions to check your answers, because the answers in the back of the book are going to look like that, or worse. The author does, I mean, he'll simplify as much as you can. But I don't care about that. That's not my goal. My goal is to do the chain rule. Do we have another one here? Ooh. Now, this one might bother you because of the way it's written. Why don't we write it this way? It's the sine of this. I'm going to have you guys try it. I'll walk around. And the 8th power is over there. This is just shorthand notation, just to mess you up. When you see sine of to the 8th, it's really all of that to the 8th. So maybe somebody wants to come up and try it. And use some colors. Yeah, that's our last one, right? This is the wrapper, the 8th. Okay? Now, it's 8 times this thing to the 7th. Does the inside under the wrapper change when you take the wrapper off? No. Then you have to do the derivative of the candy. The candy is the sine. So that's the derivative of sine, which is the cosine. Does the chocolate inside part change? No. So that still stays the same. And then now you to the, I call the good part, the chocolate part times the derivative of that. Can you read it okay? That says negative 45x, he gets ran out of room. So the negative 10, I want to make it negative 8, honestly, but minus 16x. So I got some more we can try. These are out of the book. Just leave it like that. Yeah, don't even try simplifying. I don't care what the back of the book says. Don't try simplifying. You'll get gray hair. Your assignment will take you forever. Yes. Yes, come on, pick, choose. Does that make sense? Because when you are think of the Tootsie Roll Pop, the inside doesn't change. That's the reason why we use that. Let's see what you got.
Well,
8
don't
times
you have
that.
to have a sign in there too, though?
Nope, it's times the derivative of the sine, which is the cosine of that. So that's gone.
Okay, so that's gone. So
No, that's the cosine.
no, well, I have cosine.
Okay,
so
and
I just
this
added
is gone.
that.
Right.
Yeah.
Because you have to have the sine of an angle. Now, I had this other examples here. Let's see what this one is. I did that one. Now, this is problem 11 out of 3-6. It's probably a homework question. I don't know. You can check. I don't know what's on this side. Looks complicated. Now, I want the derivative. This is a position equation with respect to time. So the operator looks like this. It's d dt. Now, do I have to worry about this constant that's in front? It's like 4/9. No. Just pull the operator through. If you want me to go through again why I can pull a constant through, I will do that. And do it. You can distribute a derivative operator. So I'm going to get ds dt equals 4 over 3 pi. Yeah, I suppose it looks different, but it's still the same process. Now, if you like parentheses around your 3t, we'll do that. This is the wrapper. The sign changes to the, well, what does sign become? Cosine. Does the inside part change? No. Then you have to multiply by the derivative of the inside part. And without the parentheses, often many of you miss the 3t. You just miss the 3. So it's times what? What's the derivative of 3t with respect to t? It's 3. Derivative of 3t with respect to x is not just plain 3. But we'll slowly go into that. So it's 4 over 5 pi. What's the derivative? Now the outside one, negative sign. Does the 5t change? No. Does it help put the parentheses there? It helps me. Times 5. If you want to check your answer in the back of the book, you can, because what's going to happen to the 3's? This 3 with this 3 are going to cancel. The 5's are going to cancel there. If you want to clean it up, so to speak, you do not have to. So it's going to be 4 cosine of 3t. Oops, forgot the pi. We never want to forget the pi, do we? Plus, or minus, 4 pi sine of 5t. Because I had a negative sign right there. I have another one. I don't know if it's a homework problem, but it's a free homework problem if it is.
Cosine t on top, or is it just still next to it?
It's the pi is still in the denominator. So if you want me to write this bar all this way, I can.
Oh.
Yes, those are the same things. Okay, because I want to get to questions too. Oh, how about this one? Let me rewrite it though. I don't like the sine cubed there. Let's write it this way. Y equals the sine of x cubed times the tangent of 4x. Like I said, what I like about the Inspire is it puts the multiplication sign in there. Because a lot of you just want to think of that as a single function and just take the derivative of all the little pieces. That's what you're thinking. You can't. You have to use the product rule. Yeah, you should copy it down and we'll try it. This is number 17. Again, I don't know if it's in the assignment. That's okay. It doesn't help. It doesn't hurt us to do more problems. If you need to do more problems, then you should do more problems. But I'm sure you're going to have some questions from 3-6. Are you ready? Okay, so it's dy. It's the derivative of y with respect to x. Well, I get a dy dx. But it really means derivative of y with respect to x. So we make a plan before I actually differentiate it. I have to use the product rule. It's the sine of x, all of that to the third power, times, and then I have to do the derivative of the tangent of 4x. That's the plan. Then what do I have to do? I haven't taken the derivative yet. I could do that first, or I could, this is the product rule. You see, that's the reason why I made the time sign really big. Product rule. Times the derivative of the sine. Oh, I suppose we could go right to the derivative of the sine, couldn't we? Right? We know what that is. Cosine of x, right? But I still have some work to do. I have to find the derivative of the tangent function. Oops. It's the derivative with respect to x. I missed the cube. I don't know where my contact spelling is. Okay, now we have to do some work. Not too bad. I'm going to start over here so I have enough space. Okay, so it's the sine of x to the third power. Do you guys remember what the derivative of tangent is? It's up there someplace.
It is.
Secant squared. Good. Now, does the inside thing change? No. And then you have to multiply by the derivative of the inside, which is 4. Most of the time, it's not going to be more complicated than this. Not the one we quit. This one's kind of complicated, but you get a partner. Plus, and then we have the tangent of 4x. And now we have to do the derivative. Oh, I even copied that wrong. It's not cosine of x. It's what? Sine of x. Because I had changed it, that's why. Okay, so now we have to do the derivative of the first one. If I kept with my plan, let's write out the plan. I wouldn't have made that mistake. Okay, first thing, what's the derivative of the cubic function?
3x.
It's 3, whatever's in there, sine of x to the second power. Now we've got to multiply by the derivative of the inside thing, which is cosine of x. Don't do anything, just leave it.
Go back.
That's the answer. It is. And you might have maybe a couple hard problems like this, not even this hard, on the multiple choice part of the exam. You might. But it won't ever be too terrible because they're not interested in can you do this so much on complicated problems or can you do it on a simpler problem and apply it. Sasha.
What's the product rule with like 3 sine, like
Would I do what with this? If I had to take the derivative again, I would. Hopefully I won't have to take a derivative again. No, you will never have anything this complicated. That's when you get your CAS calculator out and you just do it on the CAS. Because remember what's in here? What in here or inside of a Tootsie Roll Pop doesn't change, does it? So you're doing just the outer, the wrapper. So you take the wrapper off, so that's 3. You still have the candy in there, and that's squared now. If you want me to bring up my CAS calculator, we can check it. Anybody have one in there? Yeah, you have one. And it will do all of this. It'll probably, the only problem with the CAS calculator is it'll probably give me some sort of trig identities and have it all simplified. So even checking with that is going to be hard. It is not allowed on the, you can have it. Let's say this is in the calculator part of the exam. You get your CAS calculator out on the free response and you do this. You will get 0 credit for it. You're going to have to actually do the derivative. Unless it's numerical, unless you do it at a point, in which case then, if it's finding a derivative at a point, just type in your calculator and do n derive. You guys need to use the calculator when you can. How about questions on 3-6? I could do a separate video. Have you tried 3-6? I mean 3-5. 3-5. Yes. Yes. There it is. Yes. 3-5, you mean? Yeah, I moved up.
There was one question.
Oh, that looks good.
It was like describe the motion of the particle.
Yes, we have to talk about those.
Yeah.
Yeah. Is that number 15? So if you haven't done the homework, let's do this. Number 13 out of 3.5. And the only way you're going to get good at this is to practice S equals 2 plus 3. Sorry. Now we could go to parametric mode and look at the motion. It's 2 plus, we can also analyze this, 3 sine t. Okay, little practice with trig. No composite function, so it's nice. It says find the body's velocity, speed, and acceleration at some particular time. So what's the velocity? How do you find velocity? Okay, we have to know this. The change in your position with respect to time. You guys drive cars. That's what velocity means. When you go 50 miles in 1 hour, it takes you an hour to cover 50 miles. So it's the change in the distance divided by the change in time. If I do delta S over delta T, that is the average velocity. If I have ds dt, it's the instantaneous, or 1 instantaneous. So what's this velocity equal to? What's the derivative of this? I can ignore the 3. If you don't want me to ignore the 3, I won't. Can we do that at product rule on that? Show you again why I can pass the constant through the operator. So I'm going to do the derivative with respect to time of 3 times the sine of t. So it's equal to 3 times the derivative of the sine, which is the what? Cosine of t, plus the sine of t times the derivative of the 3. What's the derivative of a constant? 0. And that's why you can just pull the 3 through the operator. That always happens. That goes away. And there it is. So my velocity is 3 cosine of t. What's my speed? That becomes negative. What does this look like? Cosine, 3 cosine of t is going to put me up here. It's going to look like this in an interval from 0 to 2 pi. But what's the speed? What's true about the velocity? Here's t. Here's velocity. What's true about the velocity here? That's negative 3. But what's the speed at that time? So how do I write speed? That's right. So the speed is the absolute value. And if they ask you for that, it's most likely either something easy like this or a calculator problem. That's what they can get on the calculator, because they don't want you to have to graph some weird function and flip it up over the x-axis and stuff like that. And then it asks for the acceleration. Oh, let's do it in pi over 4. So what's the acceleration? The change in the velocity. Okay, you guys have to know this. That's your acceleration. When you start at a dead stop and you get up to 50 miles per hour, what are you doing with the car? You're accelerating, and you're changing your velocity. Actually changing your speed, but because don't think of it as a vector. But now, I want the derivative of this one. This one's harder. Let's accept derivative of 3 cosine t. It's 3 times the derivative of cosine, which is negative sine of t. So the acceleration is, I just like it cleaned up, is negative 3 sine of t. That is part A. What's B? B asks for the velocity at pi over 4, the speed, I don't have a notation for that, at pi over 4, and the acceleration at pi over 4. Is the object speeding up or slowing down? I don't know, I gotta work on it. I want to check and see if I did the particle motion on this one. Because it's kind of weird. So, evaluate the sine and cosine of pi over 4. What do you get? What's the sine of pi over 4? Oh, I put this at the end, that's right. Right, and I said to skip C. Just do speeding up, slowing down, because these are weird. I thought so. So, what's the velocity of pi over 4? It's 3 cosine of pi over 4. Now, if this is free response, you would just leave it. You don't even have to figure it out. It's 3 cosine of pi over 4. I mean, I just learned that last year. You could just leave it. But in my class, I want you to figure it out because of its multiple choice. I have to make sure you know how to do it. That's a 45-degree angle. What's the cosine of 45? Square root of 2 over 2. What's the speed? Still the same, isn't it? They're both positive. We're okay. What's the acceleration? We have to substitute it in here. So we'll slide this. So A is equal to negative 3 sine of square root of 2 over 2. Or 1 over the square root of 2. It's 0.707.
Where did you get the 3?
This 3, I put it in the derivative. Derivative's right here.
Oh,
3 cosine t. Those are good questions. Keep asking them. Because that's the cosine of a 45-degree angle. If I don't remember, I'm going to draw my triangle. And this is a 45-degree angle. So the 2 legs are equal. And then if I do Pythagorean theorem, this is square root of 2. So if I just look at the cosine of pi over 4, it's 1 over the square root of 2, which is the same as that, because I can rationalize it. No, because I want the cosine of the angle. I want the ratio. This is an angle. I want the ratio of the 2 sides. I don't care if you rationalize it. The only reason we did that was because of slide rules. Because I know what the square root of 2 is. Does anybody else know what the square root of 2 is? 1.414? 1.414, and I can take half of that in my head. Now, I have it memorized, and it's been well over 30 years since I did physics. And yet I still remember this because we didn't have calculators. 707. Use it all the time. And like the sine of 60 degrees is 0.866. You can check me out on the calculator. We didn't have it. Pretty sure that's what it is. We did everything by hand. Did you ever watch Apollo 13? All their computers went down. They did everything by hand. It was really scary. The numbers were easier, but I don't know. I think the tests were a little bit harder. Because back in my age, a 3 was good enough to earn college credit.
Well,
It is some places, but college credit for 3s everywhere. That's mean they're giving you credit for just having tried, which is cool. That's nice. Okay, what's this one going to be? This is -3 times sine of square root 2 over 2. Sine of 45 degrees, sorry. Pi over 4. No wonder I'm confusing you. Times square root of 2 over 2. Okay, here's the acceleration. Here's the velocity. Is it speeding up or slowing down? That's all I want you to know here. It's slowing down because they're opposite sides. So it's going to try to stop. We can find out where it stops. We'll do just a regular problem tomorrow with joining the motion. Just tell me that, and you say V and A are opposite sides. And be as succinct as this. Don't give me an essay. Not everybody's getting this junk. Well, it's the same thing for 15. And let's see what else we have. Other things. Anything else that look particularly difficult? They get harder as you go through the assignment. You might have questions on 21. Have you tried it? Okay, maybe we should do 21. We only got 3 minutes. Let's start 21. Because these are good problems. I'd rather see you do something than nothing. 21, y equals the sine of x plus 3. What does that graph look like? Here's my sine function. And move it up 3. Not fair. Now, Smartboard does not come on the iPads because it needs flash. I just got a Kindle Fire. I'm going to... Well, I think they might be getting it, but I know my Kindle Fire has flash, but I don't think Smartboard has an app.
It's really like the new Kindle that comes like movies and stuff.
Mm-hmm.
But like an iPad for the Kindle.
And it's cheaper.
Really?
Yeah, it's like it's 200. Way cheaper. Okay, they're asking us for the equation of the tangent line and the normal line at where? At x equals pi. So I want the tangent line and normal line. What does normal mean? Perpendicular. At x equals pi. So I want this guy, and I want this guy. There's pi. Okay, we have to be able to write the equation of a line. That's the first thing I do. Write the equation of a line. Y minus y1 equals mx minus x1. Everybody can do that? Okay, what's the y value? Y is equal to the sine of pi plus 3. I can look at my graph if I want. What's that? What's the sine of pi? It's 0, and I'm going to add 3, so it's just what? 3. Again, if it's free response, leave your answer like that. Do not simplify it. Because if you do it wrong, then we'll give you the... So it's y minus 3. But in my class, I'm going to make you do that because you have to be able to do it on the exam, on the multiple choice part. I need to know the slope, and then it's x minus pi. So far, easy? I guarantee you have to write the equation of lines. Guaranteed. You might have to do perpendiculars too. Okay, so how do I find the slope? Sorry, how do I find the slope? How do I find the slope? It's the what? But this is a function, so it's changing. You're right. It's rise over 1. It's the derivative. What's the derivative of that? Right here. Cosine of x. Now, if I don't remember what the cosine of pi is, I'm going to draw a picture. And then my bell's going to ring. Here's the cosine. So I strongly recommend that you do this. This is 2 pi. These divide in half. There's pi. What's the cosine of pi? -1. You see how I did that with a picture? So m equals -1. So now what is the normal line? It's just the perpendicular of that. So it's y minus 3 equals, what's the perpendicular for this one? +1, opposite reciprocal, x minus 1. Leave it. Leave it. It's definitely cool. Because they told me to. said at x equals pi. They could have done it anywhere. What is it? What is the tangent line at pi over 2? What is the slope of pi over 2? The slope is 0, so what's the equation of this? Because I know that this is an amplitude of 1, y equals 4. What would the perpendicular line look like at pi over 2? Can't be y, perpendicular. The vertical line, x equals pi over 2. Okay, I'm here tomorrow morning. If you are having problems, come in. Don't be shy. I might have candy. Do I have to bribe you guys to come in?
Yeah.